Our next topic is maximum power transfer theorem in DC circuits. So in this theorem, it says that the maximum power is transferred from the source voltage Vs to the load resistance RL if the source resistance is equal to load resistance. So let's see if it is true. The power in a circuit is given by I squared RL. So substitute I is equal to V divided by Rs plus RL, which is the total resistance. In order to find the maximum value of some quantity, we have to equate the derivative equal to 0. So here the differential of power with respect to RL is equal to 0. Using product rule of differentiation, write the next step. Take this term to the right hand side. So minus 2 would become plus 2. Cancel the common term V squared Rs plus RL the whole square. So you get Rs plus RL is equal to 2RL. So RL gets cancelled and we get Rs is equal to RL. So source resistance R is equal to load resistance for maximum power P. And the value of the maximum power is equal to V divided by Rs plus RL the whole square into RL. So substitute Rs is equal to RL. So on squaring we get V squared by 4RL, which is the maximum value of power, that is P max. So next let us do a problem based on this theorem. So here we have to determine the maximum power delivered to the load. So to get the source resistance, we will find the Thevenin's equivalent circuit and that source resistance would be equal to RL. So to find the Thevenin's equivalent voltage, open circuit the element RL. We have two meshes now and find the currents I1 and I2. Write the mesh equations and solve. So the Thevenin's equivalent voltage across 3 ohm is 3 into 2 ampere, which is equal to 6 volt. Next, we have to find the Thevenin's equivalent resistance RTh. So the short circuit this voltage source which was present here. So 10 ohm is in parallel with 5 ohm and the net resistance is 3.3 ohm, which is in series with 2 ohm. So again we get the net resistance as 5.33 ohm, which is again in parallel with 3 ohm. So the final value is 1.92 ohm. So now draw the Thevenin's equivalent circuit with voltage in series with the source resistance. According to maximum power transfer theorem, the source resistance Rs is equal to load resistance RL. So the maximum power would be V squared by 4Rs, which is equal to 6 squared divided by 4 into 1.92 ohm, that is 4.6875 watt.